Hi, my name's Ryan Antelek, and today I'll be presenting on the detection of the green peafowl. This is the green peafowl, Pavo muticus. It's a conspicuous bird that lives in dense riverine forests in Southeast Asia. In 2018, the species was listed as endangered by the IUCN due to its fragmented range and declining population. It requires regular population estimates, but we still have no effective standardized detection method for these estimates. A standardized method is important for comparing data across the fragments of its range, and although this bird is conspicuous in color, we've actually had trouble detecting it in the field effectively. To give you a sense of this, this study by Kong and colleagues in 2018 only found 4 live birds in 865 square kilometers of transects over 3 years. So it's important that we standardize an effective method for the detection of this species, and that's what I'll be discussing today. I'm going to quickly run through 3 methods that have been used in the past, and I'll evaluate them based on these 3 criteria: efficacy, cost, and time and effort. So the first method I'll talk about is observer interviews, and this basically consists of researchers going out and talking to local people, asking them about peafowl sightings in the past, how many they saw, male, female, that kind of information. For the study that I've cited here, the researchers focused their efforts mostly on members of the local public that would have encountered the peafowl on a regular basis. So this would be forestry staff, rangers, male elders, and hunters. Unfortunately, this is just not a viable option. It is the cheapest option that I'll present today, and it can yield lots of data by virtue of the many eyes involved, but its downsides greatly outweigh its benefits. This is very time consuming for researchers to go out and interview individual people. The survey questions require an ethics review beforehand, which just delays studies even further. There's a ton of room for bias on both sides of the survey, both in survey questions themselves, interviewee selection, and the ID of the bird by the interviewees. These 2 pictures on the side show Pavo muticus and Pavo cristatus, its sister species, the blue peafowl, which you're probably more familiar with. And you can tell that it's probably easy for mis-IDs to happen. And we do have evidence of this happening. This citation is a grant report that cites an entire chunk of a study being scrapped essentially because of the frequency of mis-IDs of this bird. Also, just to note, it's very difficult and even impossible to ID individuals uniquely using this method, so I would not recommend this. The second method I'll talk about today is acoustic arrays, and in the past this has been done with technicians spread out at known locations listening for calls during the breeding season. These technicians will listen for the calls, record their bearing and distance, and using this information and the relative position of the technicians, we can triangulate the location of individuals. This is a much stronger method than before, but it's still not my recommendation. It's relatively cheap because we're using human technicians. It does allow us to individually ID birds, although this has to be done by triangulation because we still can't uniquely ID birds by their calls, and it's effective. These 2 studies recorded almost 400 and just over 1,600 birds, respectively. It does require training for the technicians involved, though, both in protocol and bird ID. It's time consuming for them to sit out in the field and listen for birds, and the major downfall of this method is that only breeding males call during the breeding season. So that's a huge restriction on when the method can be employed, and because of that, I just can't recommend this method. The final method I'll be presenting, the one I'll recommend for standardization, is camera trapping. This involves a camera, motion triggered or infrared triggered, strapped to a tree or some other substrate that captures photos when triggered. And this is a great method for passively detecting these birds without any interference. As I mentioned, this is an automated setup. It's easy to put together and it requires no human presence for detections. This is great because these birds are skittish, and so the absence of a human observer will benefit detection rates greatly. Its best benefit is that it's effective for both sexes and all ages, and this can be extremely important for population studies in demographics. The only downside to this method are its cost. It is $30 to $150 per unit on Amazon right now. It's also time consuming for data processing, and individual ID is difficult from pictures, but I'm still recommending this method due to its usefulness in population studies specifically. I'd like to quickly thank these authors for their work in the field and their attention to the conservation of this bird, and I'll be in the comments if you have any questions. Thanks for watching.